Hello and welcome to another video. This video we're going to be continuing on with the TypeScript 175 and we're going to be doing counting bits. So in this problem you're given an integer n and you want to return an array of length n plus 1 such that for each number 0 to n you want to write the number of ones in the binary representation of this number. So essentially we're going to break this problem down into two steps. We're going to make a function to give us the number of bits that are 1 in a number, and then we will just loop through every number 0 to n and get those. So to get the number of bits in a number, let's say we have a number like 5. How do we get the number of ones? Well, it's not going to be too bad, right? So 5 is represented like this. So essentially we can just say, while the number is non-zero, let's see if we can mod it by 2 or AND it with 1, either way. And if we can, let's just use maybe bit manipulation, I guess. If we can AND it with a 1, then we will have 1 bit here, right? So we will add 1, and then we need to bit shift it, right? So essentially what's going to happen here is we're going to have some result 0. We're going to say, can we AND this with 1? Yes, we can. We can AND it with 1, right? ANDing a number with 1 will give you a 1 if its rightmost bit is a 1. So we're essentially just checking if this bit's a 1. If it is, this will be the 1. So we will get 1 here. Then we shift it left, and we want to do a logical shift. So then when we shift it left, we will get 1, 0, right? Or sorry, shift it right. To shift it right, what will happen is the rightmost bit is deleted and these get moved. So we'll have this now. We'll AND it with 1. We get 0. Shift it again. We get 1. AND it with 1. We get 1. And then we shift it again and we get 0. And that's pretty much the algorithm. Essentially, we are just ANDing with the 1 to get the rightmost bit. And we are bit shifting to get the next number. So here we have 2. And similarly, let's say we have a number like 7. Get 1, 1, 1, 1. So what would happen is we AND it with a 1. We get 1 here, shift it, which means we just get rid of this bit. So I guess I can even represent it that way, all right? We just get rid of the rightmost bit. So we get rid of the rightmost bit, and that with a 1, we get 1. Get rid of the rightmost bit, AND it with a 1, we get 1. Get rid of the rightmost bit, AND it with a 1, we get 1. Get rid of the rightmost bit, and now we have 0. So we just keep doing this bit shift, getting rid of the rightmost bit. And that's pretty much all we need to do. And the other thing you need to know is if you have a number like this, in order to shift it correctly, you need to do a triple shift, which is a logical shift, which will put zeros to the left. Otherwise, if your number is all ones, the other shift will just put in numbers that are the same as the leftmost number in the number. So let's say your number is all ones. What would happen is if you shift it, you would get rid of this, but then you would add a 1 here instead of a 0, right? And you want to replace it with 0. The other thing you could do is you could take your number and you can just divide by 2, and that would also be the same as a bit shift. But essentially, we just loop, do a bit shift, pretty straightforward. So let's code that up, pretty easy problem. Okay, so what we need to do is we need to loop for every number 1 to n, right? And we also need to represent this, I believe, as an array or something. So let's have an array, and it's going to be result, and it's going to be a number array. And we'll set it equal to nothing. And for I in range, right? So for I equals 0, and let's let I less than or equal to n. So I is less than or equal to n, I plus plus, right? And now essentially for all of these numbers, what we need to do is we need to do this like bit shifting thing. So in this loop, we can just take this number, right? And we'll just say like let num equals I, and we'll say while. Oh yeah, we also need to keep track of how many ones. So we can say like let ones equal 0, and while the number is non-zero, we will just do this operation. So while the number is non-zero, we will just AND it with a 1, right? So we'll say ones plus equal num ANDed with a 1, and you could do a bitwise AND like this. Then we want to shift left or shift right. So we'll say ones equals ones, shift right by a bit. And we'll just keep doing that. And then when the number is not there, then we will just res.append the number of ones, except not Python, so push. And finally, at the end of the loop, we will just return that result. And that should be it. So let's see what happens. Well, looks like we have an infinite loop, I believe. Let's see. I think so. let's see our issue. Yeah, so we have time limit exceeded, so let's just walk through this. Let num equals I. So typically what happens if time limit exceeded, and it's because this shouldn't be ones, this should be num. There we go. Do we have another time limit exceeded? Okay, no, we're good. Okay, and so you can see it's pretty efficient. So there is a better way of doing this that is faster that I will also link if you're interested, but this is kind of like the easy solution to this problem. So for this one in particular, the time, we are going through every number, and then every number we have to get every bit. So that would be n log n, because to get every bit in a number n, you're basically dividing by 2, which is logarithmic. So it's logarithmic, and it will be n log n time. And for the space, this would be O of 1. Now, like I said, there is a way to do this in n complexity, where you're getting the number of bits in a number in constant time that I will also link in the description of this problem if you're interested in the more optimal result. But that's going to be it for this one. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.